Senior 5 students, I welcome you to this learning platform. I am teacher Gaba Kosma, a teacher of physics and mathematics, and I am among the founders of BAC, Science Education Consultants, who are here providing you with a variety of services to help you study no matter the case, no matter the lockdown, no matter the sicknesses. We are here for you. We give you online lessons on Zoom and other platforms. On YouTube, we give guidance and counseling and so many other services. For today, we are studying Senior 5 Physics, Paper 2, and our topic is Electrostatics. Electrostatics, which you have studied right from your primary, and then you have been experiencing it. There are things that are real about electrostatics. One day, a schoolboy liked playing football. In the evening, when he went to sleep, because he was putting on a silk vest, when he removed his vest, he saw sparks. And actually, he thought it was witchcraft. We have a scientific explanation for that before this lesson ends. When you get your pen and rub it in your hair, it has the capacity to attract some small pieces of paper. What is that? What has been formed? So when you rub this pen, then the pen and the hair, both of them are actually poor conductors because this is plastic. What happens? One of the two materials will donate an electron to the other after there has been some heat that can make that electron move to the other material, meaning the two atoms become charged. The two bodies become charged. The one that gives out an electron becomes positively charged, and the one that receives becomes negatively charged. That is the same thing that happened to the boy. The boy, while putting on his vest, and he's was playing football. The vest kept on rubbing. The vest kept on rubbing on the fur or the hair on his body. And therefore, the vest became charged. Guess what happened? As the boy removes the vest, which has the same charge, this charge on this part of the vest, as it comes into contact with the other part of the vest, then is able to see sparks. They are charges, but they don't move. That is our topic of today. That is electrostatics. So then, what is electrostatics? We are studying about charges which do not move, which are at rest. So therefore, electrostatics is the study of charges which are at rest. This the study of charges are at rest. As we begin, even when God told Moses to go with the Israelites, their journey would not be simple. He gave them laws, the commandments. As we begin something new here, a new chapter, we need to follow some laws, some rules, some guidelines. And among them, we are going to go one by one. We say from your primary and O level that the like charges repel each other. The unlike charges attract each other. You don't have to forget that one. It is fundamental in this lesson. Then, there are some other words. We shall meet words like electric field. Then what is an electric field? What's an electric field? You hear somebody, somebody has an agriculture field where he or she does his or her agriculture activities. There is a play field. So then what is an electric field? It has much to do with electricity, which we are talking about, the static electricity. Then a field. So that is a region around any charge where its effect can be experienced. Then a region where the effect of a charge can be experienced. That is the electric field. If this is the charge, and it can be experienced up to this board, that far. So somebody or some charge here can be attracted or repelled by this one. Then this is the electric field. But then if any charge here cannot feel any effect of this, either attraction or repulsion, then this is not part of the field. So it means our field, if we would draw, would be stopping there. That's the term that we call electric field. We are going to look at it and we understand a lot. In primary and O level, we had words like electric field lines. Then what is now an electric field line? Yes, it is a line. So if this is our charge, then there is a line. Then what does this line show us? It shows the direction of force and the path. So therefore, what is it? It is a line showing direction and path followed by a charge in an electric field. And then we normally show it by an arrow. And this arrow will always move from the positive charge to the negative charge. We can take note of the three. So we shall have important notes. Drawn is shown by a line with an arrow from a positive charge to a negative charge. And we can have examples. Draw electric field lines between electric field patterns between number one, two positive charges. We normally call them point. Positive charges. So we say it is shown by a line with an arrow from positive charge to a negative charge. So if this is my positive charge, we normally represent it like that. And this is another positive charge. From the row we say like charges repel. So the arrow would be moving from here to there if it is attractive, but it's not. So this line that would be going there is repelled. And also this one will also be coming and will be repelled. There is another that will be going, which is repelled. Another that will be coming from this one, which is also repelled. And of course, there are very many. Now here can have those ones going. Consider any negative charge anywhere. The earth is full of charges. So these charges are this one is going away. Just consider something like that. Going to look for any negative charge. Somewhere, some negative charge. And you realize there is some point here. Here in this field, there is no force that is exerted there. There is no force that is experienced there. And this point, we call it a neutral. We call it a neutral point. We can show another one. A positive charge near a negative charge. They are still point charges. So we can have our positive here and our negative there. Unlike charges, as usual, attract. Very wonderful. Then we would have very many arrows going that way, even going that way, like that. Then I said anywhere there are negative charges, anywhere in print, anywhere they are negative, and anywhere there are other positive charges. So remember, the arrow is going to the negative from the positive. So anywhere the charges are like that. Yes, there are forces. We can represent them like that. We can have another one. We move from point charges and we can now go to plates. Now we can have a point positive charge and a negative plate. A point positive charge and a negative plate. This is our point positive charge. Can have our plate there, which is negative. So what happens? They attract. They attract. Yes. You don't finish from there. There will always be charges. Negative charges anywhere. 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 And there are many positive charges. Some arrows will be coming like this. From anywhere. Because there are plenty of positive charges anywhere. Okay? That's how we represent. We can keep representing and keep representing. There are very many. Now you can also do one. And you can do this question. Question. Show an positive charged place near each other. I just want you to do that. show that field pattern that is showing a negative. The plate is like this, and we shall still have a positive one. We want to see how do you show that field pattern. Learning must continue taking place, and that's our slogan at Back Science Education Consultants, where we are saying wherever you are, you must be living, and please keep safe, but then you must continue learning, especially science. Therefore, follow us always on our YouTube channel, Back Science Education Consultants. That's the name of our channel. Subscribe, share, like, invite others to like the same channel, so that wherever you are, you'll keep notified of whatever we keep uploading there. Be there. Our contacts are there. The phone numbers are on WhatsApp. When you are done with your question, feel free to send on any of the numbers and on our email, backeducscienceconsults@gmail.com. We shall get back to you. We shall respond so that learning continues successfully amidst all challenges. That is it for now.